written learners, welcome to our mathematics lesson. I am Skolile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. I hope you are ready for our lesson, grade 10s. We are doing 2D trigonometry. Right. We have been doing trigonometric functions since we started. Now let's look at something which is a bit different. We have to remember what we did when we started trigonometry. I'm talking about what? Trigonometric ratios. Do you remember those? Now in this lesson, we are going to apply our knowledge about trigonometric ratios to solve real life problems. And I have a lot of activities today, about 6 of them. So we have to try. If I ask you to do your work, you do it. If I give you 5 minutes, make sure that you try and finish in 5 minutes, okay? Let's be ready, grade 10s. And then let's communicate, let's engage each other during the lesson. Our WhatsApp line is 063-508-1301. Please do not wait for the lesson to end. During the lesson, let's make sure that we utilize the time and we learn effectively, okay? Right, let's start our lesson. At the end of the lesson, you should be able to solve two-dimensional problems. So we just two-dimensional problems involving right-angled triangles using trigonometry. Remember right-angled triangles? Okay, let me just remind you, but let's just talk about the pre-knowledge. Trigonometry, trigonometric ratios, we did that. And then geometry of straight lines and geometry of 2D shapes. Right. Let's try to remember what we did when we learned about trigonometric ratios. I'm going to give you a short activity. Okay? Right. And then try to do that. And then after that, we'll continue with our lesson. Let me give you 4 minutes to do this. In triangle ABC, AB is perpendicular to BC, you can see that. And then angle ACB is 43 degrees and BC is 13 centimeters. Calculate the length of AC and then calculate the length of AB. 2 minutes for each, so 4 minutes will be enough. Let's try to do this in 4 minutes. Welcome back, grade 10s. Do you remember the trigonometric ratios? What did we say? We said the sine of angle theta is equal to opposite side divided by the hypotenuse. I'm going to use theta as the angle. Usually use theta most of the times. Right, and then cosine of angle theta is adjacent side over the hypotenuse, and then tangent of angle theta is opposite side over adjacent side. Okay, and then we even talked about this acronym that we say it can assist us remember these trigonometric ratios. SOHCAHTOA. Right, SOHCAHTOA. So sine of angle theta, opposite side over hypotenuse. Then cosine of angle theta, adjacent side over hypotenuse. And then tangent of angle theta is opposite side over adjacent side. Please remember that. So now let's look at our diagram here. We have the angle, which is 43 degrees. That's our reference angle. And then if you check, we're looking for AB, which is the opposite side. And then we have 13 centimeters, which is the adjacent side. Okay, right, what do we want to find? Oh, we want to find AC. AC is opposite the 90-degree angle, so AC is the hypotenuse. Let me write H for hypotenuse. Okay, so what we want to look for AC, we have the adjacent side. So which trigonometric ratio involves the hypotenuse and the adjacent side? It is cosine of the angle. So cosine of 43 degrees, so cos 43 degrees is equal to the adjacent side, which is 13 over the hypotenuse, which is our AC. Okay, the best thing to do here is to make this one cos 43 over 1, and then you cross multiply. So it becomes AC times cos 43 becomes AC cos 43 degrees is equal to 13 times 1. 13 times 1 is equal to 13. See that? And then we want to find AC, so we divide by cos 43 on both sides of the equation. Divide by cos 43. Divide by cos 43. Right, then cos 43 divided by cos 43 is 1, and then we remain with AC is equal to, what is 13 divided by cos 43? You can just put that in the calculator. Let's enter that in the calculator. What do we get? We get that AC is equal to 17,752,5699. Then our answers we round off to 2 decimal places. So this 7 will change and become 8 because of this 5 here. Just look at the number next to the second decimal place. So if it's greater than 5 or more, then the number in the second decimal place is going to go up by 1 unit. And then if it's less than 5, it doesn't change. So AC is equal to 17,78 centimeters. Okay, right, let's go to, we're now finding the next one. We said what? Was it AB? Oh yes, AB. Right, AB. I'll give you time to do corrections when we get to the lesson. Baseline activity, just reminding ourselves about what we learned in the previous lessons. Right, AB, if you look at our reference angle, the 43 degrees, AB is opposite side, and then BC is adjacent side. So which trigonometric ratio involves an opposite side and adjacent side? It is the tangent of the angle. So tan 43, tangent of angle 43 degrees, tan 43 is equal to the opposite side, which is AB, over the adjacent side, which is 13. Again, we make this one over 1, and then we cross multiply. AB times 1. I just start with the what I'm looking for. That's what I multiply first. I want AB here, so I'll say AB times 1. I get AB is equal to 13 times tan 43. 13 times tan 43 degrees. You can put that in the calculator. 13 times tan 43, just as it is also. 13 tan 43. What do you get? You get that AB is equal to, what did I get? I got 12,122,69612. Then round off to 2 decimal places. These 2 will remain unchanged because this is less than 5. So it's going to be 12,12 centimeters. Remember, SOHCAHTOA. So we are going to be using trigonometric ratios throughout the lesson. Okay? All right. Now, I want us to discuss a few things, important terms that we need to know before we look at the examples and the activities. I want us to discuss angle of elevation and angle of depression. Do you have an idea about these two? You have an idea, isn't it? Let me remind you. Now, an angle of elevation is the angle between the horizontal, you can say horizontal plane, and the line of sight up to an object. Elevation. How to elevate? You have something when you are raising something, that's elevating. Okay, so it's something like this. Let's have a diagram. Let's have this tall building, and then I'm the observer. I'm here, the observer. My eye or my eyes are here, and then I'm looking at something up the building. You see, and then this is the line of sight. This is the line of sight. So the angle of elevation is the angle between the horizontal and the line of sight to an object. So I'm looking at something at the top of the building. And then this angle formed by the line of sight and the horizontal plane is called the angle of elevation. Okay, let me give you 1 minute to write notes. You don't need to write and draw diagrams. This is enough. You will remember, just that is enough. 1 minute, then we discuss the angle of depression. Right, welcome back. This is the angle of elevation. Now, what about angle of depression? What do you think? Okay, we're going to use the same diagram. Let's use the same diagram. Now, but I, as the observer, I am at the top of the building, and maybe I'm looking at cars in the parking, on the parking. Right, so that's angle of depression. So angle of depression is the angle between the horizontal and the line of sight down to an object. So I'm at the top of the building and I'm observing things on the ground. So the horizontal now is this one. Ignore this one. This one is for the angle of elevation. And then this angle formed by the horizontal plane and the line of sight is called the angle of depression. Okay? Right, I'm going to give you 1 minute again to just write short notes about angle of depression. This is just enough. You don't need to have the diagram. Just write that. It's enough for 1 minute. Right, welcome back, returns. Now, I want us to compare these two. Check now, if you actually look at these two angles, the angle of depression and the angle of elevation, you see that these angles are actually alternate angles. Because the horizontal planes here are what? Parallel to each other. So these two angles are what? Are alternate angles. So angle of depression will be equal to the angle of elevation. Right, let's go to our first example. Please pay attention and write your short notes as we discuss. In triangle ABC, that's the big triangle. You can see the big triangle there. Triangle ABC. AB is perpendicular to CD. We can see that. We can see this angle here is 90 degrees. And then ACD is 44 degrees. And then BCD is 53 degrees. And BC is 12 meters. Now, calculate the length of AC. We have our big triangle ABC, but inside the big triangle, we have smaller triangles. We have a triangle ADC. Do you see that? So meaning that we can find AC using triangle ADC. But there is a problem. Do you see the problem? If we look at triangle ADC there, we only have one item, which is the 44 degrees, the angle of 44 degrees, nothing else. So to find a missing side, or to find a missing angle in trigonometry, we need at least two things, two items. So it means we can have another side here. And then which side can we get? We can get DC from triangle DBC. This is triangle DBC. So using triangle DBC, we can get DC. And then after getting DC, then we can use DC and the angle and this angle to get what? To get our AC. Okay, do you see that? So now let's start by finding the size or the length of DC. How are we going to do that? DC, if we check, we have our reference angle here, which is 53 degrees. And then to this reference angle, DC is an adjacent side. And this angle is 90 degrees, remember? Adjacent angle is on a straight line. So it means angle D there is, let's call it D2. It's on D1, this on D2. Angle D2 there is also 90 degrees. So it means BC, the 12 meters, is the hypotenuse. So we have the hypotenuse, we're looking for the adjacent side. So which trigonometric ratio are we going to use there? Which involves an adjacent side and the hypotenuse. It is the cosine of the angle. So now cos 53 degrees, cos 53 degrees is equal to adjacent side, which is DC, over the hypotenuse, which is 12, right? We do our cross multiplication, or some people just say multiply by 12 on both sides. As easy as that, okay? Right, and then divide by 1, and then get 12 cos 53 degrees, when you're cross multiplying this, is equal to DC times 1, which is just DC. Then put this in the calculator. 12 cos 53, what do you get? 12 cos 53, I got 7,221780,278. Now, I am not going to round off because the question never said find DC. The question says find AC. And remember, great, we cannot round off during calculation. We're going to round off our final answer. So now we have our DC, which is 7,221780,278. Now we need to find AC. We're looking at this triangle now. Right? So our reference angle is 44. This is the hypotenuse. This is adjacent. So DC is adjacent. So again, we're going to use cosine of angle 44 in this case. So it's cos 44 is equal to the adjacent side, which is our DC, which is 7,2217,80,278. Don't round off during calculation. Over our AC. Then this is over 1. Then you cross multiply. I want AC, so let me start by multiplying this. So AC times cos 44 is AC cos 44 degrees is equal to 7,221780. Going on like that times 1, we get 7,221780,278. Okay, and then what do we do to get cos? We want AC. What do we do to get AC? Divide by cos 44 on both sides of the equation. You see, it's very easy to do 2D trick. Just remember what? Just remember your trigonometric ratios. Okay? Right. If you have any questions, grade 10, please feel free. Even send us your work. Want to see your work. 063 508 1301. Then cos 44 divided by cos 44 is 1. It's not 0. I have seen this a lot. That's why I always emphasize it. When you divide same items, you get 1, not 0. So there's a 1 there. It's not that 1 is invisible. We don't write it. Okay? But sometimes there are cases where you have to write it. Okay? So AC is equal to 7,221780,278 divided by cos 44. You can put that in the calculator and get 10,039456. We want 2 decimal places. This is our final answer. So this 3 is going to change and become 4 because of the 9. Just look at the next number. Don't worry about the numbers that come after 9. Just look at the number next to the decimal place you want. So in this case, it's 9. 9 is greater than 5. It's 5 or more. So this becomes 4. 10,04. Is it centimeters? No, meters. Done. Okay. That's an example. Now I'm going to give you time to do an activity almost similar to this. Okay? Similar to this. Are you ready to do the activity? Let's try. Rectangles. Let's try. Let's go to the activity. Right. Can you try to do this? You're doing both of them, A and B. You're finding AD, then finding BC for 5 minutes. I'm going to give you 5 minutes. Let's try. Right, welcome back, returns. Let's mark our work. I really hope that you got everything correct. Remember our WhatsApp line 063-508-1301. We want to start by calculating the length of AD. Let's check this triangle, ADC. We have an angle here, the 70 degrees, and also we have the hypotenuse. And then AD is the opposite side. And then AC is the hypotenuse. Okay, so which trigonometric ratio involves the opposite side and the hypotenuse? It is sine of the angle. So sine 70 degrees is equal to the opposite side, which is 80. That's what we're looking for. Over the hypotenuse, which is 15. Okay, like I said, let's just cross multiply or just multiply by 15 on both sides of the equation, right? Then over 1, 80 times 1 as 80, 15 times sine 70, 15 sine 70 degrees. Right, and then we just put this in the calculator. I did that and I got this. 80 is equal to 14,09, 5 is 5,38931. And then we want to find the length of 80. Let's round off to 2 decimal places. So 80 is going to be 14, then now because of this 5, this 9 will change and become a 10. So it becomes 10. 10. Okay, 10 you can write as 1 is fine. So it means 80 is 14,1 centimeters. Okay, now we managed to find the length of 80. We can use it to find the next one. What are we looking for in the next one? We are looking for BC. Okay, let me give you time, maybe 1 minute to write corrections before we go to BC. Right, 1 minute. All right, let's do BC. Oh, we want BC. BC, this is BC. That's what we want. So we need to find BD and then also find DC there. We find BD and DC, then these two will give us BC. Let's start by finding BD. So we're going to concentrate on this smaller triangle, ABD. This angle is also 90 degrees. So we have our reference angle. This is adjacent and BD is opposite our reference angle. So which trigonometric ratio are we going to use? Which involves opposite side and adjacent side. It is the tangent of the angle. So it's going to be tan 48 degrees is equal to the opposite side, which is BD, over the adjacent side, which is 14,1. We got 14,1 in the previous question. And then now we cross multiply or just multiply by 14,1 on both sides of the equation. We get that 14,1 tan 48 degrees is equal to BD. And then put this in the calculator, enter this in the calculator. What do you get? we get that BD is equal to what? I did the calculation. I got 15,659,63646. Okay, that's BD. Yes, that's BD. I got that. And then now we need to find DC. We need to find DC. Let's look at triangle. Let's see if we have space. Yes, we have space. We've managed to find BD. Now we're finding DC. We're looking at this triangle. Our reference angle there is 70 degrees. So our reference angle, this is adjacent side. And then this is the hypotenuse. Okay? So using the adjacent side and the hypotenuse. Okay, you can also decide to use 14,1, but if you're going to use 14,1, they need to be the opposite side and the adjacent side. You're going to use tangent of the angle. But let's use this 15, that way we were originally given. Right. Now it's going to be 15, so it's cos 70 degrees is equal to the adjacent side, which is DC over 15. Then again, multiply both sides by 15 or cross multiply like we were doing in the previous examples. So multiply both sides by 15, so it's 15 cos 70 degrees is equal to DC. And then we get that DC is equal to 5,130,30215. So you check, I'm not rounding off because this is not the final answer. So DC is 5,130,30215. And then we want BC. So we add these two. We add, therefore, BC is equal to 15,6596,3646 plus 5,1303. This is easy addition, isn't it? Okay, let me just write the final answer. So BC is equal to 20,79 after rounding off centimeters. Okay, right. Let me give you 1 minute to just make your corrections. And then after 1 minute, we go to example 2. Let's try 1 minute. Right, well done, Cretans. I really hope you have your notes. Now we need to go to example 2. That will be the last example. After that, I'm giving you activities throughout. Right, let's check example 2. The angle of elevation of a hot air balloon is 78 degrees. We know what angle of elevation means. Then from point C on the ground, point B is directly below the air balloon and lies in the same horizontal plane as C. Remember, we're talking about 2D. Okay, we don't do 3D. Now, calculate the height of the balloon above B. So basically, we're finding AB. It's even easier than what we did in the previous activity, isn't it? We're finding AB, but now this is like a real-life situation. Okay, right, so we're finding AB then. How do we do that? We have to say AB is what? AB is the opposite side. and then this is the adjacent side. So which trigonometric ratio involves the opposite side and the adjacent side? Which ratio involves the opposite side and the adjacent side? Tangent of the angle. So tan 78 degrees is equal to the opposite side, which is AB, over BC, which is 600. Okay, and then you can say over 1, or multiply by 600 on both sides of the equation. So it's going to be 600 times tan 78 degrees is equal to AB, which is the height of the hot air balloon, the height above B. Then put in the calculator, we get that AB is equal to 2,822,77806. Are these meters? Yes, can be kilometers. Otherwise, the balloon will be. Okay, let's cancel the old way. Right, so it's 2,822,7, and then this 7 will change and become 8 because of this 8. It's 78 meters. That's the answer in 2 decimal places. Okay, right, are you ready to do the activity? Now it's going to be activity after activity till we finish our lesson. Right, let's go to the next activity. I want you to try this. You need how many minutes? 5 minutes. Read the information on your own, and then you answer the question after that. 5 minutes. But welcome back, grade 10s. Now let's do our corrections or marking our work. Remember WhatsApp line grade 10 063 508 1301. The angle of depression from the top of the cliff to a board Q at C in the same horizontal plane as R is 43 degrees. That's the angle of depression. The board is 780 meters away from the foot of the cliff. Calculate the height of a cliff PR. Now remember we said that the angle of elevation and angle of depression are actually equal because these are alternate angles. So meaning that this angle here is 43 degrees. Okay, so angle Q is 43 degrees. And then this becomes our reference angle. We want our PR. So PR is the height of the cliff. And then we have RQ, which is the adjacent. Now we have the opposite side. PR is opposite 43 degrees. And then the adjacent side. Which trig ratio are we going to use there? The tangent of the angle. Tangent of angle. Right. Wait, what do I have here? Tangent of the angle. So tan 43 is equal to PR over RQ, which is 780. If you check, the calculations are just the same. Because we're just doing the same thing. It's now you being able to interpret the information. Otherwise, the calculations are just almost the same. Right? And then we multiply. We multiply both sides by 780, or you cross multiply. You will get that PR is equal to 780 not degrees, 780 times tan 43 degrees. And then put this in the calculator, you will get that your PR is equal to 727,3617672. PR is equal to 727,36 meters. Okay, all right, let me give you 1 minute to write your corrections, then we go to activity 3. 1 minute. Right, welcome back, grade 10s. Right, because of time, we're left with 5 minutes. So activity 3, I'm going to explain it. Okay, let's try to move together and then you will understand. Write your short notes as we discuss. This is activity 3. In a soccer game, Tabo has to take a penalty kick, a penalty, right? And then the goalposts are 2,44 meters high. That's the height of the goalposts. And the penalty spot is 11 meters from the goalposts. Okay? Right. Will Tabo's ball be above or within the goalposts if he kicks the ball at an angle of 18 degrees? If this angle is 18 degrees, will this ball be within the goalpost or it will be over bar? We want to find out. So we want to find the height of the ball when it gets to the goalpost here. Where is it going to be? How high will it be? That's A. And then B, what is the maximum angle at which Tabo must kick the ball in order for the ball to be within the goalpost? Right, let's find out. So now A, we want to find the angle. No, A, we're given the angle. Now we want to find the height of the ball when it gets to the goalpost. So now this angle they're saying is 18 degrees. And then the height of the ball when you get to the goalpost there will be the opposite side. And then the distance of the penalty spot from the goalpost is 11 meters. So we have the opposite side and the adjacent side. We're going to use tangent of the angle. So tan 18 degrees is equal to the height of the ball when it gets to the goalpost, which is h, let's say it's h for height, and then the adjacent side is 11. Okay, and then now we multiply by 11 on both sides of the equation. 11 tan 18 degrees is equal to the height. Or you say tan 18 over 1, then you cross multiply. Okay, right. If there are any questions, please send the questions 063-508-1301. Put this in the calculator. What is the height? It's going to be 3,574116659, which is roughly 3,57 meters. But the goalposts are 2,44 meters. So it means if Thabo will kick this ball at 18 degrees, it's going to be over bar, definitely. So you must maybe reduce the angle at which he's going to kick the ball. You see that? Now, the next question says, or let me give you 1 minute. 1 minute to just make corrections. We still have 2 minutes. Right, welcome back. Questions, let's do B. What is the maximum angle at which Thabo must kick the ball in order for the ball to be within the goalpost? So what should this angle be? If the height of the ball when it gets to the goalpost is 2,44 meters or less, what is the maximum angle there? So we need to find the angle. 2,44 is opposite, 11 is adjacent side. So we're saying tan theta is equal to 2,44 divided by 11. Now we're finding angle theta. So theta is equal to arctan, or the inverse of tan theta. Okay, and then over 11, put this in the calculator. Theta is equal to 12,506,74542. Now, this is the angle, but we have to be careful when you're rounding off here. Because if we round off using the rules of rounding off, it's going to be 12,51. And the ball is going to be over par when you do that. So we round off in context. Here we round off in context. So we have to round down. So it has to be theta is equal to 12,50 degrees. It can't be 12,51. It's going to be over par when you do that. So you round off in context. Right, and then I want us to take a short break. After a short break, I'll just give you homework, then we summarize the lesson, then we're done. Let's take a short break.
The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
Right, welcome back, grade 10. This is your homework. You can check this later, and then or take a picture of this, and then after that you can do it, and then let it be checked by say or ma'am there. Right, this is your homework. Let's take pictures if we can, or we can come back to this and copy the homework and do it later. Okay. Right, so let's move on to the summary. We didn't have any discussions through WhatsApp. Please, let's do that. If there are any questions, let's make sure that it's written homework here, summary. Okay, sorry for that. This is summary. Let's make sure that we discuss during the lessons. So we used these trigonometric ratios a lot in our today's lesson. Remember that sine x is opposite side of hypotenuse side, cos x is adjacent side of hypotenuse, and then tan x is opposite side over adjacent side. Did I say it right here? Yes, sine x is opposite side of hypotenuse. Okay, and then we are done, grade 10s. Thank you very much for joining us. We are here every Thursday, 9 a.m. In the next lesson, we are going to be dealing with statistics. We are going to look at the mean of ungrouped data, and also the mean, not mean only, the measures of central tendency for ungrouped data and the measures of central tendency for grouped data. That's what I'm going to do next week. Let's meet next week, grade 10s. Goodbye.